Welcome to the third NextBASIC tutorial concerning sprites. You will definitely have to watch tutorial 2 before doing this one because we're going to use the same program, which is a sort of bare bones pac-man game that we started to develop in lesson 2. So we've got the pac-man sprite moving around, being animated, bumping into walls. So the next thing is to put one of the ghosts into the program and handle collision detection with another sprite. So this should be interesting. So we're going to need to design a ghost. I'll show you the one that I made. There it is, occupying slots 4 and 5. Just 2 frames of animation, the little tassel things along the bottom of the ghost moving. So you can design something similar to that for your program. If I wanted multicolored ghosts, I would go on and design those over here, but one will do just for teaching purposes. Alright. Let's call up our program as it stands so far. Now, this is going to involve pac-man dying. I could just put a stop statement in, but I think I want to make it a little bit more interesting looking, so let's do a little subroutine of pac-man going through his death throes. So I'll go way down to line 9000. And I'll create a subroutine that I'll call from another point in the program. So, player death. Okay, let's do a little loop here. 8 times, say. And I want the pac-man sprite to spin around while making a noise. Okay, so let's start with a display statement for the sprite. Sprite 0, that's our player, XY coordinates, and pattern number 0, which is the sprite facing to the right, binary value, 2, 3, 4, 5, 6, 7, and that's normal. Okay, so I want to repeat that 4 times. And you'll remember this from lesson 2 where we tweaked these binary values to change the direction of the sprite. So that's rotate right 1. That's facing left. And that's facing up. Rotate right and flip vertical. Okay. Now in between these I think I'll just make a beep statement using the old Spectrum buzzer. Let's see, duration 0.3, note. We let the note follow the I of the 4 next loops so that it will change the tone as it goes through. And I'll repeat that 4 times as well. Wrong line number, hold on. Need that, so put that in 50, 70, 90, and let's close off the loop at that point. Whoops. Okay, that should be an interesting looking death routine. I'll run my program just to activate the sprites, and then I will break into it and go to line 9000 just to see this in action. Okay, that'll do fine. Now we need to get the ghost on the screen. So we're going to need some variables to track where the ghost resides and where he moves to. So this is my initialize variables section at the beginning of the program. So let's do something for the ghost. We've got X for the player, so we'll call it GX for the ghost, and then GY for the ghost's vertical position. Now, I could just do another let statement, but I know that ultimately I want 4 ghosts. And it's as easy to program 4 as it is to program 1 if I just use dim instead of let. So I can give, using dim, I can give GX 4 values for 4 different ghosts. Whoops. There we go, and we'll do the same for GY. But I'm only going to concern myself with 1 ghost at the beginning. And then once we've got 1 working, we'll get all 4 working. Okay. We'll not worry too much yet about the direction of the ghost. Although we do have 2 frames of animation, so we better do GZ. Now the ghost is just alternating between these frames, so I don't need to do dim GZ. I just need to do one variable for that. GZ equal 0. Yeah. Well, it's actually patterns 4 and 5, isn't it? So let's actually set it to 4. It's going to alternate between patterns 4 and 5. The pac-man sprite occupies patterns 0 to 3. 4 and 5 will be the ghost. Yeah, that'll do. Okay. Whoops, what did I do wrong? I know what it is. You can't. This is something I forgot from Spectrum Basic. You're not allowed to have dimmed variables that have 2 letters. They're only allowed 1 letter. So let's call it G for the ghost's horizontal position and H for the ghost's vertical position. We'll just have to remember that because we've already used X and Y variables. Possibly it will allow me to use X and Y and it will keep those separate from those X and Y values, but I'm not going to take a chance on that just yet. So G and H for the ghost's X value and the ghost's Y value. Okay. Slightly confusing perhaps, but we'll just have to remember that. Right, that's what we need for the ghost. Now let's display the ghost on the screen. Well, hang on a sec. We better give these ghosts some initial starting values. So let G brackets 1 equal, and I'll just pick these randomly. Let H brackets 1 brackets equal 50. So there's a ghost. It'll be somewhere around the top left part of the screen. And we'll do all 4 ghosts, even though we're only going to use one of them for the time being. Okay, so that's ghost number 2. Ghost number 3. We'll do it at, let's just start it at 0. Well, we want it to be on the screen, so let's start it. No, let's bring it properly onto the screen. 80 comma vertical value, let's go with maybe as high as 200 or 180, say, somewhere down the bottom of the screen. Ghost number 3. And ghost number 4, horizontally start him at 30, and vertically, where haven't we used? Somewhere in between, 150. 4 ghosts with various starting positions. Oh, I made a mess there, didn't I? Good job, I saw that. That would have been insane looking. Okay, put that one at 200. Why not? Okay, there's our 4 ghosts defined. We want to display them on the screen now. So let's just get the first one going. This is our display section where we're displaying the player, so it makes sense to display the ghost at the same time. So first ghost is going to be sprite number 1, and it's going to have the X position G1, the Y position H1, and it's going to have pattern number, what was it again that we called it, GZ. Yeah, and it's going to be visible. We'll not worry about doing binary values for that because at the minute we're just having it all face the same direction. Okay, that's the sprite on the screen. Let's run this and make sure we can see it. There it is, up in the top left. Very good. But there's no collision obviously yet, so you can see what happens. Pac-Man just slides along underneath the ghost. Pac-Man goes underneath because Pac-Man is sprite 0 and the ghost is sprite 1. If I had those the other way around, Pac-Man would float on top of the ghost. We saw that in the Connect 4 example from tutorial number 1. Okay, that's good. Now, well, I suppose it's just as easy to get all 4 ghosts visible as it is to get one. So why don't I actually do that right now while I'm in that section of the program? And I can do that with a little for next loop. Okay, where are we? Where are we? Gone too far. So there's sprite 1 there. So there are 4 ghosts, so for I equals 1 to 4, and it's going to be display a sprite number I, which is G, instead of G brackets 1, it's G brackets I for its X coordinate, and it's H brackets I for its Y coordinate. Okay, that's good. Okay. And as usual, I forgot to close my loop, which I tend to do sometimes. Next I, that's better. Four ghosts. I didn't pick a very good position for this one, did I? So let me make an adjustment here to that one. That must be very short I value, very long, sorry, short X value, long Y value. Let's put it somewhere else, like maybe here and closer to the right hand side or something. So let's see what one that is. It must be the fourth ghost. Its X value is 30 and its Y value is 200. So let's bring that Y value up to 150. And let's bring the X value a little further onto the screen, pixel number 40. Okay. Oh, he's going to start on top. Oh, this one starts on top of Pac-Man. That's no good. And I've made an integer out of range. Okay, I'm making a real mess of things here. No wonder I did 1500. Right. But the one that starts on top of Pac-Man is no good. It must be that one. So move him over to there. That's better. Okay. You have to give the player a chance after all. Right. There's our ghosts on the screen. Let's get them animated. So that's a case of tweaking this value GZ. And I want to do that down in, where's the best place to do that? Probably movements, maybe. Let's see. That's the player movement, so we're going to do the ghost movement. 5100 rem ghost movement. Alright. All we want to do is increase the value of GZ, so it changes from 4 to 5. Let GZ equal GZ plus 1. If GZ has gone beyond 5 to 6, then throw it back to 4. Okay, that should get our ghosts not so much moving, but at least shivering a little bit on the screen. And there you can see, hopefully you can make that out. There's a little bit of movement here on the bottom of the ghost. Right. Now, shall we get the ghosts moving before we actually handle collision? Or shall we do collision first, just to see it happening? Let's do collision first. Right. Took a little while for me to figure this out. I'm going to begin another new section at 3000. And we're going to call it, you could call it collisions, but I'm going to call it consequences. And this is where I kind of need to explain my own particular style of programming arcade games. I basically have a personal mantra when I'm constructing a game, and it's basically, there's a loop which I call main loop in this, beginning at line 1000, and it goes round and round and round, and within this loop are 3 overall sections, and they're called display, consequences, and movements. Let me just put a capital C on consequences there, just to help with my OCD. No, I don't have OCD. But display, consequences, movements, and they have to be in that order. If you did movements before consequences, your program wouldn't function correctly. I'll just explain. So in the display section, you would basically just display your sprites and any other information that you want to show up on the screen. That's the first thing you do so that everything is visible to the player. Now before you allow any movement, the first thing you need to do is to check if there are any consequences to the sprites being in the positions that they are in. What needs to happen as a result of what has just been displayed? That's consequences. Then, assuming the player survives that, we go to movements where we allow the player and the enemy and anything else on the screen to move. Then we go back round to display, and all this is happening several times a second. Hopefully, 25 times a second or even more if you can get away with it. So this is a very fast loop that goes round and round and round very, very rapidly, and that's how the game works. If you did movements before consequences, you get some strange things happening, because you display your sprites, you'd allow the player to move, but bear in mind, all you're doing is changing the X and Y values of the player and the enemy and other things. You're not actually reflecting those values on the sprites until you get back around to display. So the values will be wrong in relation to where the sprites are displayed. So if you then check the consequences after the movements, you're checking consequences based on positions that those sprites aren't yet on the screen. If that makes any sense. Clear as mud, yeah? Okay. Display consequences movements, that's my mantra, and it keeps the code nice and tight, nice and logical. So, the player touching the ghost is a consequence, right? Death is a consequence of the player and the ghost touching. So that's why it's here at line 3000, not down below the movement section at line 6000. It has to be after display, prior to movement. Alright? So, what kind of logic do we need to get these two things touching? Well, I've made a little note here. Hopefully you can see that. Don't concern yourself with this one here at the bottom yet. Just concern yourself with this one at the top. There's the Pac-Man sprite sitting somewhere on the screen, and the value here at the top left of it represents its actual XY value, which is always the top left corner of a 16 by 16 sprite. Alright? Now don't pay no attention to the fact that there's a big border around Pac-Man. Obviously it's supposed to fill the entire area. Same with the ghost. I just drew it like this for clarity. So there's Pac-Man's XY value. So imagine here we have a ghost attacking Pac-Man from the right hand side. When the two sprites touch, we know where the ghost is in relation to where Pac-Man is. The ghost will be 16 pixels exactly to the right of Pac-Man in terms of the X vector, right? Forget about Y. This is just a horizontal attack for the time being, right? So basically, collision occurs if ghost, which is our H variable, it's our G variable. If the ghost is exactly 16 pixels ahead of X, alright? Equally, the same thing happens on the left hand side when the ghost is exactly 16 pixels to the left hand side of this, like so on, right? So that we could use the expression, let's see how I would reflect this in an if statement. If ghost, now we'll just do ghost brackets 1, okay, that's the ghost's X value, equals the player's X minus 16, okay? That will work for the ghost on the left hand side. The ghost position equals 16 minus the player's position minus 16. Can you sort of get a sense of the logic here? So the same is true for the other side, right? That would be plus 16. I'll just draw some arrows in here so you can kind of see what I'm talking about. There's the player, there's the ghost. So that's plus 16 and that's minus 16. Okay? Right. Now that's okay for a horizontal attack. There's also a vertical attack which could be programmed in just the same way. However, something like this can occur, this bottom one, where pac-man and the ghost meet on a corner. So if you look at this, the Y value is definitely 16 pixels below, right? From here to here. That's 16 below, right? But the X value is not exactly on the edge. It's not 16. It's actually less than 16. It's maybe 10 pixels, or it could be 7 pixels, you see? So this is an actual collision, but it's not exactly, it's not exactly on the corner here where 16 is, because you can meet like that because we're moving 1 pixel at a time, So how are we going to do that? Well, the logic has to be a little bit different. Don't do exactly 16. Do it like this. If the ghost's X position is within X minus 16 and the ghost's X position is within it from the other side, so less than X plus 16, okay, then go to 9000, which is my, it's 910 if you like, which is my death routine. Now, will we test that and see if that actually works? Now we've only done the horizontal, and we've only done sprite number 1, okay. Now I can't remember which one is sprite number 1. I'm hoping it's this one here. I think it is. So there you go. Perfect. Let me take the megahertz up a little bit here because things are starting to slow down. We're dealing with more sprites. And let's do it from the left hand side, make sure it actually works. Oh! Now that's interesting. I died there because I was only doing it was this here, it's this, I'm only measuring the X variable, so it's this whole column kills me, right? So we need to add more things here. So let's add in the Y as well as the X. Now, we can do it all on the same line. It's just the identical logic of this flipped over with Y instead of X. So it's and the H is the ghost's Y position is greater than the player Y minus 16 and and the ghost's Y position is less than the player position plus 16. Right, that should be accurate. Hopefully it'll let me go through. Yes, it's not killing me this time. But if I go up here, oh, I can't, here we go. Let's see if it'll die this time. Yep, working perfectly. Let's see if I can die when I touch the bottom. Yep. Let's see if I come in at an unusual angle like this, like I'm meeting the sprite on the corner. Yep. Let's check the top. Oh, that's not quite right, so we have an error there. Let me see what's going on with that. Yep, better check my logic here. Right. Ah, of course. I did X instead of Y. Silly me. Good, and collide. There we go. Now, the one drawback of this is it's treating the sprites as if they are entirely square. Now, Pac-Man isn't square, he's round, which means a collision will occur when I touch the round corner of Pac-Man to the round edge of the ghost, and it will probably not look as if there's a real collision there. See? But it is a collision in terms of an actual 16 by 16 block. So I don't know how to make it any more intricate than that. In Spectrum machine code, even for the 48K, people created things called sprite masks that allowed you to be much more intricate, but I think that's beyond the scope of BASIC, at least at the moment. It would be really nice if we had some means within BASIC of noticing when sprites are actually touching or overlapping in relation to where their transparency is, so that could be detected. It would take a lot of work off it, and it would make our games run faster. So maybe that's something that the developers of BASIC might want to integrate into NextBASIC in the future, because I know there is some development still underway for it, but for the time being I found this to be quite a good little system. Now it's very easy obviously to make all the sprites be detected. That's just sprite number 1 I was dealing with, so this is the one here that determines which sprite it is. So just like I did a for next loop to display all 4 sprites, I can do a for next loop to check that the collision on all 4 sprites. So for I equals 1 to 4, g brackets I so now with that little change, being careful to close off my loop, with that little change underway, I should be able to collide with any sprite. Oh, it's not working. I always make mistakes. Right, let's see if this one's still working. Yep. Okay, I need to split this up a little bit into separate lines because I'm starting a for loop and then I'm making a conditional statement, and it will only go to next I when the condition is true, and that's a mistake. I need it to go to next I whether the condition is true or not. So trying to do too much in one line, not always a good idea. Yep, take that out. I'll just rename that to line 20 and then take away the next I from that line. Okay, that should work now. Here we go. That's better. And we'll just be thorough and we'll check one of the other ghosts down here. Okay, so now we want to get the ghost to move about the screen. So we've already got a section here for ghost movement, so I'm going to add some more things to that. We'll keep it simple. I'll just get all the ghosts moving to the right, and then when they go off the right hand side of the screen, we'll put them back onto the left hand side again. So a little for next loop should do it. For I equals 1 to 4, because there are 4 ghosts. That's the horizontal position of each ghost, equal g brackets I plus 1. And when it reaches the right hand side of the screen, so 5140, if g brackets I equals, so there are 320 pixels across on this layer, the sprite layer. So 320 minus 16 is 304. I'll just go to 303 just in case. then set it back to 0. Close off the loop. I think that's all I need to do. This is the first time I've done this part actually. I'm not referring to my notes for this part. So let's see if it works. Wonderful. Moving ghosts. And all of them can be collided with. I'll just wait for death. Yeah, it's working fine. Let me just check what megahertz I'm at. I'm at 28 megahertz. So this gives you a sense of what BASIC can do with 5 sprites on the screen and collision detection active on all of them. So if I'm honest, it's a pretty slow running Pac-Man game, and this is the maximum speed that you're going to get. So we've really hit a bit of a serious limitation here with NextBASIC. There may be some shortcuts you can take and some ways of optimizing the code. The one thing that I'm not doing is using integer variables, which I should be doing. So that should speed things up a little bit. Yeah, it's okay. I gotta say, it's not too bad as a Pac-Man game with these sort of sprites. But if I'm gonna add any more sprites with collision detection, things are gonna slow down considerably. But it's really nice to get it working like that. Yeah. I should also say that if your sprites are not 16 by 16, for instance, if you had a character that was tall and thin, like Miner Willie, you can still use this little routine here. It's just instead of doing 16 and 16 in your horizontal, your X positions, you would have 8 and 8 or 10 and 10 or whatever sort of width you wanna experiment with, and it should allow for any sort of rectangular shape, whether it's a perfect square or a tall rectangle or a squashed short rectangle. You just have to adjust these 16s to something else. For instance, if I wanted to give a little bit more grace in the collision, I could take this back to 13 instead of 16. If I didn't like the fact of this sort of collision that wasn't really a collision at the corner where Pac-Man's curved edge met the ghost's curved edge, then it just didn't look like a real collision. I'll take it down to 13 and let's take a look at what happens when that same sort of collision occurs. So I'll position Pac-Man at the point where he's going to meet the corner of the ghost. Should be coming up soon. Let's see what this looks like. Oh! Not working. Yeah, it is working. I gave a little bit too much grace. Let's go to 14 instead of 13. Just takes a bit of experimentation. Let's go and catch this guy. Yeah, not perfect, but better than it was perhaps. It also means you can kind of you can kind of outrun Pac-Man a little bit, even though you're slightly touching him. Yeah, not bad for a collision routine in BASIC. So this is the structure of the logic that you want to remember. It's all done in one line with 4 AND statements, tackling the left-hand side, right-hand side, above and below. And this logic will automatically tackle any attack that happens on a diagonal from where your sprite is. Yeah. Okay, so that's collision.